Alrighty, this is Calculus 2, and it is not Despacito 2, okay? Sorry about that. Okay, Despacito. Despacito? Yeah, I know, I was trying to actually say it. Yeah, I couldn't say it. Sorry. Anyway, alright, so differentiate the product and quotient of two functions, higher order derivatives. Okay, now, we've done this already, and I don't know if you guys actually had it previously in the same format. My format is slightly different because quotient rule and product rule are the same format. They're the same format, okay? So if you put it in the same order every time, you just know, hey, quotient, I have a subtraction and I have it over g squared, right? Yeah. Okay, so we set it up the same way. So, yeah, so I changed the product rule a little bit. Blah, blah. Okay. Okay, so if I'm actually taking the derivative, okay, that's what this means right here. Ooh, dang, forgot to calibrate. Okay, now I'm back after calibrating my thingy. All right, there we go. So right here, so we're taking the derivative, and this right here, I have a product in between here. There's a multiplication happening in between those two. So, in other words, I'll jump down to the bottom because this is the easiest way to do it. If I'm taking a derivative of two parts of this and I'm multiplying them together, I do f prime g, so that means the derivative of f times g plus the derivative of g times f. Okay, it's slightly different than what you might see in the book, but I changed this order because it's the same as the quotient. Okay, it's always f prime g and then g prime f. Okay, so let's take a look. So now, this is a product rule here. This is a product rule. So let's take a look. So f is going to be 1 plus x squared. F prime, so take the derivative of f is going to give you what? 2x, right? Yeah. So I get 2x. Okay, and I have g is e to the x, so g prime is e to the x. Okay. All right, so if I'll put it together, let's go. It's going to be f prime g, so it's going to be 2x times e to the x plus g prime, which is e to the x, f, which is 1 plus. Okay, there we go. And so now from here, I really can't do much. Just put it together because I could distribute this or I could factor out. What could I factor out? I could factor out an e to the x. So if I take out an e to the x, I'm going to be left with 2x plus 1 plus x squared, right? Yeah. So you could rearrange this as needed, but okay. Okay. Now, right here, find derivative, differentiating product in two ways. Okay, product rule, multiplying factors, okay, and finding the derivative. So, we could either do product rule here, or we could do the distribution. So, I would distribute this, distribute it all the way, and then do product rule, or multiply it. So, let's try A, product rule. Okay, so, this is my F, and this is the G. So on this one, so it's going to be f prime. So I'm just going to leave f up there. So f prime is going to be what? 10v minus 1? Yes. Okay. G prime, 3v squared. Okay. So if I do the product on this, it's going to be, let me see, f prime, so it's going to be 10v minus 1 times g, which is v cubed minus 1 plus my 3v squared times f, which is 5v squared minus v plus 1. So go ahead, and I have to do some distribution anyway. So I'm going to distribute this. So I get 10v to the fourth, right? 10v to the fourth minus 10v, then minus v to the third plus 1, and then as I distribute this, it's plus 15 v4 minus 3v3 plus 3v squared. Combined like terms, I get 25v4 plus 3v squared minus 4v cubed. Oh yeah, they're out of order, I'm sorry. What's the next one? Minus 10v. And then I get plus 1. Okay. So I distribute, nothing cancels out. I'm left with just a mess like this, right? So that's one way of doing it. Now I could actually do it again using multiplying instead. So we can multiply first and then take each derivative. So do I have it on the next sheet also? No, I don't. All right, so now I'm going to erase. So if it's going to be 5v squared minus v plus 1, v cubed minus 1. So I'm going to do my distribution. So I'm going to change colors on this because I feel like it. So start here. So I'm going to distribute from the binomial into the trinomial. So it's going to be 5v to the, what is it? Fifth, right? Add exponents, right? Okay, so, and then here, so that's going to be minus 3, no wait, not 3, minus v to the 4, right? Right here, plus v to the third. All right, so let's go to the next one. So now, as I distribute over here, I get negative 5v squared. As I distribute over here, that's going to be my plus v. And then from here to here, it's going to be minus 1. Okay, so do they have any common variables? No like terms? Say no. No. Okay, no like terms, so I'm going to get 5v to the 5th minus v to the 4th plus v to the 3rd minus 5v squared plus v minus 1. Yes. Okay, so now we're doing the derivative. Okay, so now I did the multiplication first and do the derivative. So this is going to be 25v to the 4th minus 4v cubed plus 3v squared minus 10v plus 1. Hopefully that's the same thing I got the last time, right?
Yes. Yeah.
Okay. Are we okay? All right, quotient. Now, quotient is slightly different, but, okay, so when I'm dividing two of these together, it's going to be, I rewrote it like here. So f prime g minus, now quotient's a minus sign here. So f prime g minus g prime f over g squared. Okay, all that's going to be over g squared. All right, so now right here, so I'm going to list it out. So my f prime is going to be what? So it's f on top and g on bottom. 2x g prime 2. So it's f prime g, so it's going to be 2x g, which is 2x minus 3, minus g prime f, which is 2, and x squared plus 1, all over g squared, which is 2x minus 3 squared. Okay? So on an AP exam, on the free response, leave it like this. Okay? You would leave it like this, but you guys have to actually, on the multiple choice, you would actually have to work this out because your solution has to match their possible answers. So if I distribute here, I'm going to get 4x squared minus 6x minus 2x squared minus 2 all over, I'm just going to leave this 2x minus 3 squared because that one's already factored. Okay, that one's already factored, so I don't want to mess with that. So combine like terms, I'm going to get 2x squared, right? So 2x squared minus 6x minus 2. Okay, can I factor that more? Nope, it won't factor. All I can do is take out a 2, right? I can take out a 2. So I can't really do anything with the top. So you want to check to see if you can, though. Okay? You want to check to see if you can. So if I could factor anything in the top, then I might be able to cancel something in the bottom. 2x minus 3 squared. Okay? So this is my, what's the notation they use here? Y prime here. Okay? All right, reciprocal of a function, it's just going to be the derivative, basically. So you take the derivative of 1 over g. So you're taking the derivative of the reciprocal. So we took g, turn it into 1 over g, then take the derivative of it. So because what's the derivative of 1? 0, right? So my f prime would equal 0, wouldn't it? Yeah. Yeah, so that whole first part of this, that's why it turns into minus g prime over g squared. Yeah. They do the whole quotient rule, but they just like try to simplify it and say, oh, it's just this. But you could do the quotient rule to get the exact same thing. Okay? So, all right, and I don't know why I did this. Oh, yeah. So right here, so if we're doing this, taking the derivative, I don't know why it's all blurry, but we took the derivative 1 over this because on the top we know it's going to end up going away, right? Because the derivative of 1 would be 0. So that's actually using the same thing that we just did. Do the quotient rule on this. Now, with the negative exponent, we know that that could move down to the denominator, right? Or if it was in the denominator already, that would go up to the numerator. Yes? Okay, so if I were to take the derivative of that, I make it 1 over e to the x, and then derivative of e to the x, the 1. Okay, it's all the same thing here. Okay, we could do this as chain rule also, but not yet. All right, so if I were to write this one right here, okay, this is going to be rewritten as 1 over x, right? So I know, if I looked at my previous one, so it should be like this. So it should be minus g prime over g squared. Okay, g prime, what would g prime be? Over g squared. X squared. The same thing works for my chain rule, right? Okay, so, and yes, there should be a negative there. All right, so if I did the chain rule, so it is x negative 1, right? I don't even have to do chain rule. Put the negative out, right? So 1, so right there, and then I subtract 1, right? So x to the negative 2, which gives me 1 over, negative 1 over x squared. So it's the same thing, it's just another way of doing it, a little bit easier. I don't know if you even consider it easier. Okay, same thing goes for this. So that would become, so let's say, what's the derivative of this? 2u, so it's going to be a negative 2u over g squared, which is u to the fourth, right? U to the fourth. Yeah, squared. And so it's going to give me negative 2 over u to the third. Now if I just take the normal derivative, so let's turn this into u to the negative 2. Okay, put the negative 2 out front, right? Negative 2 out front. Then it goes u to the negative 3. Pull that back down. Negative 2 over u to the third. It's the same thing, right? Just power rules, just a different way of showing it. All right, do I need to show this one too? No? Or yes? No. We good? Okay. All right. Second, third, fourth derivative. So, y prime. What's y prime? 6 x y double prime. 12x the jerk. And y to the fourth is I don't even know what the fourth represents. I looked it up before. I don't know. Maybe. Change in jerk. I don't know. Okay. Find second, third derivatives of this. Okay, what type of rule is that? Product. Okay, so if I use product on this one, so I know that my f prime would be 2x. G prime is e to the x. So if I'm using product rule, it's going to be 2x times e to the x plus e to the x times 1 plus x squared. Yes? I'm hoping no one's just playing on their phone right now. Or is it just too trivial? Okay. Alright, so that's going to be my first. Then I can factor out the e to the x. And it's going to be left with, let me see, x squared plus 2x plus 1, right? Yeah. So this is my y to the first. Second derivative. So it's again product rule, right? So this time I made this my f prime would be e to the x. G prime would be 2x plus 2, right? So it's going to be e to the x times x squared plus 2x plus 1 plus, that's going to be e to the x again, and then it's going to be 2x plus 2. Yes? Factor out that, so it's still my y double prime, e to the x, and I'm left with x squared plus 4x plus 3. All right, do I need to keep going over this over and over? Same thing? Okay, if you distribute this, it makes it a whole lot easier because it turns into a whole bunch of products, right? If I were to distribute the e to the x into here, every time we have that, that would be another product. So that would just make more work on yourself. And I think that's, yes, that's where I'm leaving off today. All right, so you guys got the homework. Don't forget to like and subscribe. Hit that notification button.